Hi everyone. Um, I am recording this lecture as part of a four-part series on hemostasis, coagulopathies, blood transfusions, as part of comprehensive review lecture. Welcome to my home. I'm going to do this at home today because I have the right software on my computer at home, and it's a little more comfortable than being in the office all the time. So I hope you guys enjoy watching these lectures. I hope they help you if you didn't have an opportunity to do the standalone hematology class. Then this is going to introduce you to these topics. If you did do standalone hematology, then hopefully this is a review from several semesters ago, so it might feel like it's brand new information. We're going to go ahead and do this first topic on hemostasis, just basics of how to stop blood from leaving the body. And then we'll have separate downloadable videos on each of the different subtopics within hemostasis, like coagulation disorders, coagulation testing, and then finally blood transfusions. So let's go ahead and begin. All right, so first of all, hemostasis. We got to talk about what exactly this means. So hemo means blood, and stasis means to stop. So hemostasis is the process that causes bleeding to stop. This is basically how the body prevents just chronic hemorrhage in all of our patients and ourselves. So let's talk about hemorrhage. Hemorrhage is basically the medical term that we use for bleeding, so we can use these two terms interchangeably, hemorrhage and bleeding. Coagulopathy is a defect in coagulation, which means that our patient is unable to stop bleeding, and there can be lots of different reasons why a patient might have a coagulopathy, and we'll talk about that in a separate bleeding disorders video. So stay tuned. And then the last thing we should talk about when it comes to terminology having to do with coagulation and blood clotting is thrombosis. Thrombosis is the formation of an abnormal clot, or a formation of a clot in an abnormal time or an abnormal place. So a good example of this might be with cats with hypertrophic cardiomyopathy. If you'll remember back to vet disease, we talked about how cats with hypertrophic cardiomyopathy sometimes will form blood clots within the heart itself. They start in the left atrium, move down to the left ventricle, get released sometimes into then the aorta, where they finally come to a stop at the external iliac arteries, creating an aortic thromboembolus or saddle thrombus. We call it both those things. And so that's an abnormal pathological clot. It's a clot we don't want in a place we don't want it, and that would be thrombosis. So let's talk a little bit about the steps of hemostasis. As you can see from the picture down here, we have three basic steps of hemostasis. First, we have vasoconstriction. Then we have platelet aggregation, or primary hemostasis. And then finally, we have secondary hemostasis, or clot formation. Let's talk a little bit more about those. Vasoconstriction is exactly what it sounds like. Vaso means vessels, blood vessels specifically, and then constriction is constriction of those blood vessels. So this is when we have an injured blood vessel. The smooth muscles of the blood vessel will kind of constrict down and cause that tube of vessel to become smaller, and that helps to slow down the flow of blood and hopefully helps to minimize any blood loss that's occurring. Next, we have primary hemostasis, which is the formation of what we call a platelet plug. You can see down here on the image, platelet plug, these little purple guys all sticking together. The platelets will aggregate in this area by the injury, and they'll form like a little plug. And that's great, but if that's where it stopped, unfortunately that platelet plug would get damaged and knocked off pretty easily. It's a pretty fragile structure. So next we need that secondary hemostasis, which is also called coagulation. And this is the solidification of that clot, that platelet plug into a clot. There are little proteins that are circulating throughout the bloodstream called clotting factors. These clotting factors will join the platelet plug and then will help to form this fibrous molecule called fibrin that kind of stitches it all together and makes that plug turn into a clot and help prevent bleeding. We'll go a little bit more in depth to each of these steps right now. So firstly, vasoconstriction. Again, like I said, this is caused by smooth muscle contractions within the blood vessel walls. And that's going to cause, as you can see in this image here, constriction, or basically a tightening of that blood vessel. The lumen, or the center of the blood vessel, is going to get narrower, and that should slow down the flow of blood through that vessel. It's going to limit blood loss by helping to reduce the amount of blood that's flowing through that vessel at any one time. And so this is kind of the first step in helping to reduce the flow of blood and helping to reduce blood loss from our patient. If you put pressure on an area that's been injured, like with a bandage, or direct pressure with your finger or a gauze square, this can help to increase the vasoconstriction and therefore decrease blood loss. So, whenever we have either an injury to our patient or a place where we've, done some venipuncture into a vessel and our patient could be bleeding, putting pressure directly on that injured site or on that venipuncture site is going to help to improve vasoconstriction, decrease blood flow, and then decrease blood loss from that vessel or those vessels, depending on the size of the injury. The second step is this primary hemostasis, or formation of the platelet plug, and this is an incredibly important step. You guys know from all the way back to hematology or VCLP1 that platelets are important for helping us clot our blood. But we don't really talk about exactly how they do that. Well, here is the time when you get to learn about how they do that. So we're going to get this formation of a platelet plug. And what happens is that when the walls of the blood vessels are damaged, we get these exposure of fibers of collagen. Down here you can see in this image. All these little collagen fibers start to stick into the blood vessel there. And what that does is that triggers those little platelets to stick. And the more platelets stick, and they kind of trigger this cascade reaction of platelet stickiness, and they all aggregate together. We get release of this factor called von Willebrand factor, and that helps to stimulate the adhesion of platelets to each other. And then this is going to activate those platelets as they travel by. So again, blood is flowing through the blood vessel here. We have these little platelets. These are these little ovals. As they enter the area where there is an injury, you can see the von Willebrand factor represented by these little circles that are sticking out. These platelets get activated, and they basically start to form these little these little legs that stick out from the platelet, and that makes them become more sticky. Think about it sort of like a burr. If you walk through the woods and you get a burr attached to your clothing, and a lot of times it attracts other burrs, and they just kind of all connect to each other. So these platelets are sticky once they're activated by the von Willebrand factor, and they're going to stick all together to form that plug at the site where the vessel is damaged. And that von Willebrand factor we'll talk about later when we talk about some of our coagulation deficiencies. But for right now, we know that von Willebrand factor is helping our platelets stick together. Here's another image that kind of shows you what happens. Here we have an injury to our blood vessel wall, and then we have represented here by these little purple squiggles is our von Willebrand factor. Red blood cells are here, and then these are platelets right there. So as the platelets run by the von Willebrand factor, they get activated, and they get these little long legs that stick out that make them sticky, and then they start to stick to each other, and then more platelets come by and get activated and start to stick, and so now we've got this primary platelet plug. Very helpful little device going on right there. I love the awkward Yeti. So here's some platelets, and they're running by, and there's a platelet party. This guy says, "What's going on here?" And they get stuck, and there's a platelet party, and it's a big platelet party. They're all stuck. So there you go. And there ain't no party like a platelet party, because a platelet party stops your patient from bleeding out. We're not done yet. There's more to come when it comes to coagulation. So secondary hemostasis. This is really where that platelet plug gets solidified, and so your patient really does stop bleeding from this injury. We call this coagulation as well. And this is a reinforcement of that platelet plug with a fibrin mesh. So fibrin is represented in this image here by these little orange strands. And then this is an electron microscope picture that's been colorized. So the red blood cells are here in red. There's a little white blood cell right there. And there are platelets stuck in here as well. They're just hard to see. All of this yellow fiber that you can see here is fibrin. You can see it's almost stitching together these red blood cells and platelets within the platelet plug to hold it in place. So it kind of acts like a glue or like thread to sew everything in. And this is that final step that's going to complete the creation of the blood clot. So secondary hemostasis is where, in addition to completing the clot, it also gets pretty complicated. And we're going to introduce you a little bit to some of these complicated parts of hemostasis, but not too in-depth. So just kind of bear with me here. So there are two pathways that are part of this process of secondary hemostasis. The first one is called intrinsic. An intrinsic pathway occurs inside the vessels, intrinsic inside, or intravascularly. So this is coagulation that's happening inside the blood vessel. And if you remember back to that picture, we had some of that platelet plug or clot inside the vessel, and some of it was outside the vessel. You have to have sealing of the vessel on both sides. And the second half would be the extrinsic, and this is also called the tissue pathway. It's also outside the blood vessels or within the tissues themselves. So you can intrinsic inside the vessels, extrinsic outside the vessels. This extrinsic pathway is started by exposure to this compound called thromboplastin, and this is coming from damaged tissues outside the blood vessel wall. So whenever we have an injury to a blood vessel, including a venipuncture, it's not just the blood vessel that's damaged, it's also all the tissue that's surrounding it. And so those other cells outside the blood vessel are going to release thromboplastin, and that helps to accelerate the clotting process on the extrinsic pathway, which is outside the blood vessels. Now, both of these are going to end and come together in what's called a common pathway, and that common pathway is going to lead to those strands of fibrin being produced to solidify and hold everything together. Now, let's talk a little bit more about how this happens. So I mentioned before there are these proteins that are called clotting factors, and they are circulating constantly within the bloodstream. You may remember back to vet disease that clotting factors are produced by the liver, and when we have especially liver failure or even severe liver disease, we can have reduction in creation of these clotting factors, and then your patient can start to have bleeding disorders. If you'll remember when we talked about leptospirosis and infectious canine hepatitis, and even hepatic lipidosis in cats, all of these liver diseases can become serious enough to reduce production of clotting factors. So this is really important part of the step, is that the production of the clotting factors within the liver itself. Now, when blood vessels are damaged, remember I said thromboplastin is released and collagen is exposed. Thromboplastin is released by the blood vessels as well as the tissue outside the blood vessels. Now, this thromboplastin basically acts like an activator, and it starts that clotting factor to begin going through the intrinsic and extrinsic parts of the coagulation cascade. Now, this is a series of actions by 12 different clotting factors, and this is eventually going to lead to solidification of that platelet plug into a blood clot. This is a graphical representation of what happens when we have an injury. So we have the intrinsic pathway, we get to expose collagen. The extrinsic pathway gets exposed tissue and damaged tissue and release of thromboplastin. And then all of this goes through until finally we get formation of fibrin and then the cross-linking of fibrin, which is how that platelet plug turns into a blood clot. Now back in my day, back when I was in vet school, I had to memorize this entire coagulation cascade, extrinsic and intrinsic pathways, and the common pathway as well. Luckily, you guys don't have to, so don't panic. Let's just go over the basics. This is really important for you guys to know, but you don't need to know all of the specifics of all the coagulation cascades. All right, so let's talk about basics. We talked about the coagulation factors. There's at least 13 different ones. There's 12 clotting factors, and then there's some other factors as well, like von Willebrand factor. They all work together to stabilize the clot. Also, there's been new coagulation factors discovered since I graduated from vet school 16 years ago. So, yeah, they're learning more all the time about how this works. So we mentioned this before, but there are two pathways. There's the intrinsic pathway, which is going to occur intravascularly or inside the blood vessels. And then we have the extrinsic pathway, which is going to occur extravascularly or in the tissues. And these are both going to start when we have release of thromboplastin, and also collagen is exposed from the damaged blood vessels. This is all going to accelerate that clotting process. Both of these pathways are going to end in the formation of fibrin. Fibrin is very important. Remember that. And those are the strands of protein that hold the platelet plug in place and create the actual clot. To go over these pictures again, here we have a vessel injury, some sort of trauma, exposure of collagen here from the vessel. Then we have von Willebrand's factor release and aggregation and stickiness of platelets to make this little platelet plug. And then finally we have the coagulation cascade that happens intravascularly, intrinsic pathway, and then extravascularly, extrinsic pathway, to finally end in the common pathway to form these strands of fibrin to hold that plug in place and create the blood clot. That's what it looks like with an electron microscope. Okay, and that's the end of hemostasis. So make sure you understand all that. There will be a worksheet that you can download from DocSharing to help you work through this. If you have questions, you're welcome to email me or Dr. Lisa. My email is jchansen@argosy.edu. Dr. Lisa is lwilbert@argosy.edu. Thanks so much, guys. And we'll see you next time. Bye.